Okay, so here's some geometric sequence situations where the nth term is equal to the first term times the common ratio raised to the n minus 1, where the common ratio can be found by dividing two consecutive terms, much like in the arithmetic sequence where you subtract two consecutive terms. In geometric, you divide two consecutive terms. So in this case, it's pretty clear that we're multiplying each term by a half, so there our common ratio is a half. Our first term is 64, so we want to find the 8th term and the nth term of the sequence. So let's do the nth term first. It would be 64 times 1/2 to the n minus 1. Well, I find these both have 2 in common here. So I'm going to rewrite 64 as 2 to the 7th, I believe. 2 to the 6th. 64 as 2 to the 6th. And then this is 1/2 to the n minus 1. Well, then now I'm going to write this as 1/2 to the negative 6. Reason being is this is a base of a half, so I want this to be a half. In order to take 2 and turn it into a 1/2, I need to have a negative exponent. So notice that these two are equivalent. Just rewrote it, so therefore I can add the exponents. So I get 1/2 n minus 1. So I can combine the exponents here. So I get a sub n is equal to 1/2 to the n minus 7. So the 8th term would be 1/2 8 minus 7, which is equal to 1/2. So here we're looking for the nth term again. It's pretty clear that our first term is 5/3. The only question is, what is our common ratio? Well, again, the common ratio can be found by taking the quotient of two consecutive terms. So in this case, it's 5/6 divided by 5/3. 5/3 divided by 5/6. And probably the easiest way to handle this is just two fractions being multiplied. So it's really just 5/3 divided by 5/6, which is 5/3 times 6/5. And these cancel and that cancels, and you're left with 2. So the common ratio is 2. So our nth term is equal to 5/6 times 2 to the n minus 1. And therefore our 8th term is 5/6 times 2 to the 7th. So 2 to the 7th, I believe, is 128. So 128 times 5 divided by 6, and let's simplify that fraction, is 320 over 3. Our next one doesn't look very geometric, but it actually is. We're dividing by, I believe, a tenth. Let's just verify that. Our common ratio is the quotient of two consecutive terms, so 0.04 divided by 0.4. 0.4, is 0.1. And let's do another common ratio, so 0.004 divided by 0.04. That also is equal to 0.1. So a sub n is equal to 0.4 times 0.1 to the n minus 1. I'm going to do a little simplification here as well. I'm going to write 0.4 as 4 over 10 and 0.1 as 1/10 to the n minus 1. I'm then going to rewrite 4/10 as 4 times 1/10 times 1/10 to the n minus 1. Now I have the same base and I can add the exponents, so I get a sub n is equal to 4 to the 1/10 raised to the n. So the question is, what is the 8th term? The 8th term would be 4 times 1/10 to the 8th. So that would be a sub 8 would be 4 over 10 to the 8th, which is equal to probably 7 zeros. So 4 divided by 10 to the 8th is 7 zeros. 1, 2, 3, 4, 5, 6, 7, 4. These are consecutive terms in a geometric sequence. We've seen a problem like this with arithmetic sequences. In this case, we're going to determine what the common ratio is. So the first common ratio of the first two consecutive terms will be x over x minus 1. The common ratio of the second set of terms would be x plus 2 over x. Well, since these are in the same sequence, the ratio must be common. So therefore, these two common ratios must be equal to each other. So that's x over x minus 1 equals x plus 2 over x. And we just cross multiply. So I get x squared equals x minus 1 times x plus 2. I multiply the right-hand side. I get x squared plus 2x minus x plus 2, which gives me x squared equals x squared plus x plus 2. The 2x squareds cancel, so I get 0 equals x plus 2, and x equals negative 2. Find the ninth term of the following sequence. Pretty clear my first term is radical 3. The question is, what is the common ratio? Well, the common ratio is always the quotient of two consecutive terms. So we divide negative 3 divided by radical 3. I'm not really a big advocate of rationalizing the denominator, radical 3 over radical 3. I get negative 3 radical 3 over 3, which gives me negative radical 3. So my common ratio is negative radical 3. So the ninth term, or let's do the nth term at first, is radical 3 times negative radical 3 to the n minus 1. So we want to do the ninth term, which would be radical 3 times negative radical 3 to the 9 minus 1. So that would be 8. So that would be the ninth term, would be radical 3 times, this is going to be positive, and an even power with the negative is positive. So this is 3 to the 1/2 to the 8th. So that's radical 3 times 3 to the 4th. 3 to the 4th is 81, so we get 81 radical 3. Find the first term of the sequence where the fifth term is 64 radical 2 and the common ratio is radical 2. So our formula is a sub n is equal to a sub 1 r to the n minus 1. Our fifth term is 64 radical 2, so 64 radical 2 is equal to the common ratio raised to the 5 minus 1. Our common ratio is radical 2. We're looking for the first term, so that's a sub 1. So I just took all the given information, plugged it into this formula right here. So I have 64 radical 2 is equal to a sub 1 radical 2 to the 4th power. Well, this is 64 radical 2 equals a sub 1, 2 to the 1/2 to the 4th. Power to a power, you multiply those two, so I get 2 squared. So I get 64 radical 2 equals a sub 1. 1/2 times 4 is 2, so I get 2 squared. So I get 64 radical 2 equals 4 a sub 1. Divide both sides by 4. I get a sub 1 equals 16. Radical 2. Tricky.